Okay, we are finally on to topic number 8, which is financial mathematics. Okay, so we've got 3 parts here. Number 1 here is currency conversions. Now, this is a pretty good topic, actually. A lot of kids in the IB travel a lot, and it's good to know how to convert currency to see how badly you are getting screwed by the bank. Okay, or the currency exchanger. Actually, I was just in Vietnam and I bartered down a currency guy. It was pretty cool. Anyway, the best way to do these problems involving currency conversions is to set up a proportion. Okay, so the amount you want to find is just X right here. Okay, so let's say you wanted to convert. You had $800. Okay, and you wanted to convert to euros. Okay, something like that. Okay, so I always do it this way. I just put euros here, and then I know I have dollars, so I just put dollars here. Okay, and let's see the amount given. So the amount given, well, they give us $800. Okay, now what we need to do here is to find the exchange rate, and I'm just gonna, I don't know, I'll go online right now and find the exchange rate. Okay, as of today's rates, 1 US dollar, whoa, 1 US dollar equals 0.77 euros. Okay, so all you have to do is, we would put the 1 right here and we put the 0.77 here. Now to solve it, 1 times x is x, and 800 times 0.77, whatever that is. I'll just break out my calculator right now. 800 times 0.77. So you get 616 euros. Okay, so that's how you do a currency conversion. Now, the tricky part here, and for everyone who uses euros, sorry for my euro sign, it's bad. Wait, can I make this? Whoop, two, boom. Okay, still bad. I've been to Europe a bunch of times, but whatever. Okay. When the tricky part is when you have buy and sell rates. Okay, buy and sell rates are given. When they're given, remember to use the rate that is worse for the customer. So the one that the bank does better on. Okay. So for instance, what I always do is I set up the proportion. Okay. So I find my X. I have the currency they give us. Whatever goes here. Whatever, in this case $800, and if they have 2 rates, okay, depending on how the rates look, if you have to multiply, so if the currency is going to go right here, you're going to use the lower rate, and if you're going to divide, you're going to use the higher rate. Okay, so it's not that difficult, quite frankly. I mean, you can do it both ways. You can use both rates, and whichever one's lower is the one that's right, because the bank's not going to want you to make money. Okay. Now, if there's any commission that needs to be taken off, you can do that at the beginning or end of the problem. It really doesn't matter. So you just need to know how to take a percentage. So oftentimes they'll say something like 2% off. So let's say you have $800 at the or well, in this case, let's say you had 616 euros. And the commission was, I don't know, 2%. So you just do, 616 times 0.02, and that is 616 times 0.02 is 1232. So that's the amount of euros you'd have to pay in commission. Okay, so currency. This is a good topic. Now, what I'm going to do now is I'm going to link to a video I did on this where it goes over this in pretty big detail. Again, it's not a big deal. Just set up the proportion here, x over what's the amount that's given, and then put your exchange rates here and just solve it. If the numbers, there's one of these is going to be a 1. Okay, so if this is a 1 and that's a number, like in this case, multiply. If this is the number and that's the one, you just divide. And you should be good to go. So I'm going to link to that, or put that video right behind this one right now. Alright, for this video we are going to go over currency conversions, which is a pretty important topic. It's actually really a good topic to know, like especially if you travel. I remember once I was in Prague and I got absolutely destroyed on a currency conversion because I was being stupid, and I regretted it. I mean, I'm a math teacher and I lost out on this. It was not cool. Anyway, let's look at this. It says a bank in Canada offers the following exchange rates between Canadian dollars and euros. The bank sells 1 Canadian dollar for 0.82 euros and buys 1 Canadian dollar for 0.78 euros. A customer wishes to exchange 800 Canadian dollars for euros. All right, the important thing you guys need to take out of this is basically that there's two rates here, and you need to know which one to use. Well, this is a bank in Canada, so they're dealing in Canadian dollars. So you need to ask yourself, for the first question, find how many euros the customer will receive. Okay, so he has Canadian dollars, but he wants euros. So what is the bank doing? Well, the bank is buying his Canadian dollars. So we are going to use this rate right here, the second one. Okay, so let's figure this out real quick. So let's look at A. Now, the best way to do these is just to set up a proportion. I always do, let's see, he wants to buy euros. So we'll put euros on this side, and then he has Canadian dollars. Now, you can just set it up like this. It's nice and easy. And we're finding X here, how many euros. Now he has 800 Canadian dollars. And underneath is where you put the rate. Okay, well, we decided that we were going to use this rate right there, the second one. And why are we doing that again? Because basically what the bank is buying Canadian dollars. Okay, so we will do 1 Canadian dollar. We put that with the Canadian dollars to 0.78 euros. Now this is pretty straightforward to solve. You just do 1 times x, which is x, and then 0.78 times 800, or 800 times 0.78. So if we put those together, let's see, it would be 800 times 0.78. What do we got? 624 euros. Okay, so he gets 624 euros. And the reason it's less is because the euro is stronger than the Canadian dollar. Although probably not for long, because the euro is going down and the Canadian dollar is going up. As of right now, it's October of 2012. Okay, anyway, let's look at part B. It says the customer has to cancel his trip and changes his money back later when the rates are sell 1 Canadian dollar for 0.815 euros and buys 1 Canadian dollars for 0.779 euros. Now usually these rates are really long. I just rounded them, so it's a little easier. But if you went to like, you know, a money exchange place, the rates are like, I mean, they're probably 10 decimal points long. We use the we sell information to find how many Canadian dollars received. Okay, well in this case he's just changing his money back because his trip got canceled. So we're going to find how many Canadian dollars this time. And then we are going to, he has euros here, so we'll put 624. Now again, you have to look at what rate you're going to use. Well, what is the bank doing here? The bank is selling him Canadian dollars, so we are going to use this one right here. Wow, that was a pretty straight line. That was pretty cool. Okay, anyway, I have horrible handwriting, so I'm really proud of that. You guys are like, Bueller. Quote that. No, that's an easy movie. Ferris Bueller's Day Off. All right. Okay, so what do we got here? So let's get going. 1, and then it would be 0.815. Okay, now all you really have to do here, this is x, and then this is 624 divided by 0.815. Okay, so let's see what we get here. Oops, that's not what I want. That's my recording software. So we will do 624 divided by 0.815. And we're going to get $765.64. Okay, so $765.64. All right, so $765.64. Now, if you look at that, he started with 800 right here, and now he has 765. So that the difference there is the bank commission. That's how the bank's making money when they change this money. Okay, so basically part C says, well, how much did he lose in the transaction? Well, he actually lost quite a bit. Okay, so 800 minus, 765.64, and so we can just do, let's see, 800 minus 765.64, and we get 34.36. Okay, and then this is going to be in Canadian dollars, so it's going to be to 2 decimal places. Okay, so 34.36. Now that's quite a bit of money to lose. I mean, he started with 800, so you know, it's not quite 5%, but that's a little over 4% of the money lost just by exchanging the money twice. And that's what you'll see generally worldwide. The rate may not be that bad, but you are, you know, going to lose money, and you should shop around to try and get the best rate. So anyway, I hope that helped out. You know, basically, what you can take out of this is set up a proportion, always solve for, you know, whatever you're solving for, put for X right here. You know, just set up a proportion. The buy and sell rate, just think of the bank. You know, if it's a bank in Canada, they're gonna, you know, they're dealing in Canadian dollars. If it's a bank in the U.S., they're dealing in U.S. dollars. If they're a bank in Thailand, they're dealing in Thai baht, that kind of thing. And you know, and a good rule of thumb is, you know, when you're converting to another currency, you know, you use the smaller number, and when you're going back to their currency, it's going to be the bigger number here. You know, if we use the other numbers here, the person would gain money, and obviously that's not going to happen. Okay, so anyway, hope that helped. Take it easy. Okay, for section 2 here, it's simple and compound interest. Problems with simple interest need to be done by using the formula that is provided. Okay, the simple interest formula is right here. Okay, the interest is the capital, that's the initial amount, times the rate, which, you know, let's say like 5%, number of compounding periods, which is like 5 years, and then you just divide it by 100. That gives you your interest. The only trick with these ones is, you know, if they ask you for the total, you have to add in the initial amount, the capital, back to it. So, you know, if you find out your interest is, you know, 500, you know, on an initial investment of, you know, $3,000, if they want the total, you would just, you know, it's 3,500. Okay, now that's pretty straightforward. Now with compound interest, it can be compounded annually, which means one time per year, monthly 12 times per year, quarterly 4 times per year. Be careful when using the finance app. If you're calculating monthly or quarterly interest, you have to change the PY and the CY to 4 or 12. The N will be either in quarters or months. Okay. Now, if you're going to use the formula, okay, so you know, these formulas are pretty straightforward. C is capital, interest rate. Now, this one you would use for annual interest right here. Now, if you see this one has a K in it, the K is just the number of compounding periods. So if it was monthly, it'd be 12. If it was quarterly, it'd be 4. Semi-annually, it'd be 2, etc. And a lot of this is just plugging in. Now, the only trick to this is when they actually want you to find N. That can get it can get a little tricky. You can use the solver, you know, on the graphing calculator. You know, just turn it on and go to Math, arrow up, and go to Solver, and press Enter, and enter this in. And make the equation equal to 0 and enter it in. You can do that, but it's much easier to use the finance app. Now remember, if you're going to use the finance app, you need to write down the window as you're working, so the examiner, you know, can see that. Now what I'm going to do right now is I'm going to link to 2 videos that I did on this. One where I show you how to do it, you know, with the formula here, and then the second one I'm going to do on the calculator. So it gives you a pretty good idea of how this works. So I will link to those right now. Alright, in this video we're going to go over compound interest, which also has to do with geometric sequences. And the best way to go through this is go through a typical IB problem. This is a paper 2 problem. So it says on Vera's 18th birthday she was given an allowance from her parents. She's given the following choices. Choice A, $100 every month of the year. Choice B, a fixed amount of $1,100 to be invested at an annual rate of 12% compounded monthly. C, 75 for the first month and an increase of 5 every month thereafter. And 80, the first month an increase of 5% every month. Okay, so this kind of takes into account a lot of the stuff we've done with arithmetic and geometric sequences. Part A says, assuming that Vera does not spend any of her allowance during the year, calculate for each of these choices how much money she will have at the end of the year. Okay, so let's just start off one at a time here. We'll start with choice A. Okay, and choice A is pretty simple. It's 100 a month for 12 months. So you just, do 100 times 12, and you get 1,200. Okay, that's pretty simple. Now, if it's simple, it's probably not going to be the right answer, but we'll see. All right, let's do B here. All right, a fixed amount of 1,100 to be invested at an annual rate of 12% compounded monthly. Okay, well, with this, you're going to want to use the compound interest formula that's in your formula booklet, and that formula is the future value equals the present value times, let's see, 1 plus the interest rate over 100 times k, all to the kn. Now, this looks kind of complicated, but it's actually not that bad. What this is, okay, so future value is FV, present value. R is the interest rate. K is the number of compounding periods. So if it's a yearly, you just leave it alone. It's 1. But like, for instance, if it was quarterly, you would put 4. In this case, what does it say? Monthly. So we're going to put a 12. So I'm just going to put, we just want to see what our future value is going to be. So the future value is going to be, she starts out with $1,100 times 1 plus, what's the interest rate? 12% interest over 100 times 12, all raised to, now it's 12 compounding periods, and it's just 1 year, so it's going to be raised to the 12th power. Now, if you were to simplify this, you would get 1,100 times, okay, what's that? Let's see, 12 over 1,200 is 0.01, so plus 1. So if you do all that in the brackets, you're going to get 1.01 raised to the 12th power. Now, we can bust that out on the calculator, and we can just enter it in. Let's clear this out here and get 1,100 times, and then I'll put the 1.01. You don't really need to put it in brackets, but I'm going to do it anyway. It's a good habit to get into, and then raised to the 12th power. So let's see what we got there. Okay, 1239.51. Now this is dollars, so you're going to go to 2 decimal places. So future value is 1239.51 in dollars. Okay, now you can see that that's better than 1,200 for the first one. Now, choice C, let's see, it says 75 for the first month, an increase of $5 thereafter. Okay, that's an arithmetic sequence. Okay, so we can use the arithmetic sequence formula to get our sum, because they want to know how much for the year, right? So remember that this is n over 2 times 2 times the first term plus n minus 1 times d. Now, I mean, you could add them all up if you want, but this is much quicker. So the sum of 12 is going to be 12 over 2 times 2. Now, the first term is 75 plus 11. 12 minus 1 is 11. And then d, what's d? 5. Okay, so it's only going up by 5 per month, but it will add up quickly. So this is the sum of the first 12 is going to be 6 times, let's see, that's 150, 205, right? 150, I should probably use the calculator, 205, and so that's going to be $1,230. Okay, so that is actually lower than the one before, so we don't want that one. It's actually lower than part B. Now, for part D, okay, 80 for the first month, an increase of 5% every month. Okay, well, that's a geometric sequence. It's increasing 5%. Now, the only trick with this one is basically, okay, so it's a geometric sequence. We're going to go, we can use the geometric sequence formula, which is the first term times the ratio to the nth term minus 1 over r minus 1. Now, in this case, it's going to be the 12th term. The first term is 80. Now, the ratio in this case is kind of tricky. It's going up by 5%. Now, you can't do just 0.05 or 5. What this is if you actually put it into this formula here, the 1 plus 0.05, the ratio for this is going to be 1.05. Now, okay, 1.05, what is it, raised, hold on, let me just put a bracket there, raised to the 12th power minus 1 all over 1.05 minus 1. Now I'm kind of running out of room here. Let me show you why that is. Okay, if the first term is 80, and 5% of 80 is 4, so the next term would be 84. If you divided those, 84 divided by 80, you'd get 1.05. Now I know that's a little tricky. Some kids get confused on that. But I guess a shortcut for that is just to add 1 to the decimal. Okay, so we'll break out the calculator here, and we'll do, clear it out, and we'll get 80 times 1.05 raised to the 12th power minus 1. Okay. And that's going to be some big number, probably 63.66. Okay, fine. And then 1.05 minus 1 is just 0.05, so we're going to divide it by 0.05. And so it's going to be 1273.37. So 1273.37. So 1273.37. Okay. Now, if you were to look at these, if we're going to look at all these totals, let's look what we got here. We got the first total. Where's my pen? Oh, there it is. Okay, we have what, 1200, and then the second we have 1239.51. The third we have 1230, and then we have 1273.37. So obviously it says part B, which of the choices do you think Veer should choose? Well, obviously you would choose 1273.37 because it's the highest one. Now, you got to be careful on this. I was talking about this with some of my students, and they're like, well, I would choose the 1200 up front because, or the 1100 up front because I'd spend it quicker or whatever, and you don't want to use that kind of logic on these tests. They don't know your parents, so just go with what is right. One person was talking about giving money to charity. That was awesome. And yeah, while a noble effort, probably not going to work. All right, let's move on to the third part of this problem. Okay, so the third part says on her 19th birthday, Vera invests $1,200 in a bank that pays R% interest per annum compounded annually. Vera would like to buy a scooter that costs $14.52, or $1,452 on her 21st birthday. What rate will the bank have to offer her to enable her to buy the scooter? Ooh, I spelled buy great too there. That's awesome. Okay. Now, what I'm going to show you how to do on this one, if you solve it using the formula for compound interest, is actually going to be more difficult because you're going to have to use logarithms or a square root. So what I'm going to show you is on the calculator. If we take our calculator out, what you can do here is you can go to apps and then finance, and then TVM solver. Now this will be on your calculator. They can't remove it when they clear your calculator for a test. Now the beauty of this is that this is going to solve for us. So it says she invests $1,200. Well, that's the present value. $1,200 is PV. Okay, so for PV, now because she's giving them $1,200, you have to put this as a negative number. Okay, now it's kind of a weird thing, but if you don't do it that way, it's not going to work. So that becomes negative. It's because she's putting the money up for it. I guess that's one way of looking at it. Now the future value, what does she want for the future value? Well, she wants $1,452. Okay. Now, okay, so 19th to 21st birthday, so that's 2 years. So you're just going to put N right here for 2 years. Now, PY is payments per year and compounded yearly. This is, the interest is calculated per annum, per year. So we don't have to change these. If it was quarterly, this would be a 4, and that would be a 4. If it was monthly, it'd be a 12 and a 12, and I'll do another problem like that some other time. So what we want to calculate is the interest rate here that she needs. So the way to do this is you just use the solver. You go to alpha, which is well, it's the green button on the TI-83. What color is it on the TI-84? I can't remember. Anyway, alpha, and then solve, which is the enter key. And you'll see that it's 10%. Okay, now what I would do here, if I were you, is I would just, if you're going to show your work here, I would show, I would show what the calculator says. So the interest rate is 10%. The present value is negative 1,200. Let's see, what else do we have? I wish it would stay up. And then payment that's always going to be 0. Okay, and then the future value is what she wants, how much money she wants, 1452. And then payments yearly, which is just 1, and compounded yearly. I would write this on your just put a box around it, and so the person who's grading your exam knows exactly what you're doing, that you're using the solver. And that's a totally valid method of doing it. And it's actually very easy. If you get to the solver, solving for a future value with the equation is easy, but once you try and find n and r, it's not easy. You have to use logarithms or square root. There's a lot of algebra involved. So I would highly recommend that you get good at the solver. And again, to get there, you just go to apps, you go to finance, you go to TVM solver, and then there's going to be basically 4 things: n, the interest rate, then the years, present value, future value. They'll give you 3 out of 4 of those, and you solve for the other one. Now the only other thing is you might have to change the PY and CY, but we'll bust one of those out later. Anyway, hope this video helped. It's running a little long, so I'm going to cut it short. Hope there's not too many mistakes. If there are, oh well. No, I'm just kidding. I'll check. All right, take it easy. Later. All right, on this video we're going to do a compound interest problem, second compound interest problem, and this time it's just going to be compounded quarterly. And what I'm going to do is I'm going to show you how to do it with the calculator. The first examinations for IB 2014 says you can use the finance app on the calculator. You don't really have to show your work on it. So all you need to do is really write down what you're putting on the calculator. Now, what it says here, oh, by the way, this video is dedicated to my friend Cracky. Yee. All right, here we go. Joe places $5,000 in a bank account that pays 4% per annum compounded quarterly. Okay, the thing you need to know about quarterly is that it is 4 times per year, quarterly. So what they can do is they can do monthly, quarterly, or semi-annually. Semi-annually is twice a year. Quarterly is 4 times a year. Monthly would be obviously 12 times a year. Okay, so the more it's compounded, the more interest you're going to get. That's basically the rule of thumb. So what he originally starts with $5,000, okay, after 7 years. Okay, so the way we would do this is in the finance app, you have, it goes N, which is the number of compounding periods, or the number of periods, the interest rate, the present value, the payment, which is always 0. You don't have to worry about that. The future value, that's what we want to find. And then the payments per year and the compounding per year. Okay, so if we're going to look at this problem, I always just like to fill in what we have here. So it says he starts with $5,000. Well, he's putting up the $5,000, so that the present value is always negative. So you just put negative $5,000 here. The way I look at that, you're putting it up, so it has to be negative. If you put both of them positive, it's not going to work. That's the problem. Now, if you do leave this positive, your future value is going to be negative, which it doesn't really matter. Obviously, it's going to be more than $5,000. Okay, so the interest rate is 4% per annum. Now, it's compounded quarterly. Okay, so we're going to find the future value. So we're going to find this right here. Okay. And then it's compounded quarterly. So this is, both these are going to be 4. They're always the same. Now, how many? The n is the kind of tricky part here. Okay, so how many payments are there going to be? Well, if there's 4 per year times 7, so 7 times 4, you would get 28 different payment cycles. And this is actually pretty relevant to real life, like when you have a car payment or something like that for 5 years, 12 times a year, you know, you have 60 payments. So anyway, this is going to be 28 payments. So what we can do is we can break out the calculator here, turn it on, and I'm just going to enter in all my stuff here. So I got 28. Let's see. Interest rate's 4. Present value, again, make it negative. In this type of problem, if you don't make it negative, it's actually not that big of a deal, but it's a good habit to get into. We're going to find the future value, the payment's 0, and then these are both going to be 4. Okay, so what we need to do, the payments always, or the end and beginning is when it calculates the interest at the end of the year, the beginning of the year, or the end of the compounding period, actually. So don't even worry about that. It's usually at the end. And then future value. So now we need to solve. So what you just do is you go to alpha and press the enter key, which is solve. So it's going to be 6,000. What is it? 6,606 and 45 cents. So 6,606 and 45 cents. Now, be careful with a question like this because, you know, if it's dollars, you usually have to go to 2 decimal places. Sometimes they'll say to the nearest dollar, which would be, you know, 6,606. So just be careful because you can lose a point of financial penalty for that if you're not careful. So anyway, that's that. Now let's see what we got for Part B. This is where you kind of have to work backwards a little bit. Joe decides to withdraw the money when there is $5,634 and 13 cents in the account. How long has it been in the account? Okay, so this is, we kind of have to work backwards here. So we have, let's see, NI, present value, payment, okay, and then future value. So we actually know that. And then PY and CY. Okay, so again, let's see here. Okay, so we're going to assume it's still compounded quarterly. They don't say otherwise. So these would both be 4. The future value, they give us a future value. So that's 5,634 and 13. The payment is always going to be 0. The present value, well, that's just what he started with. So that's negative 5,000. Now here in this problem, if you put both of these 5,000 and 5,600 as positive, you're going to get an error message on the calculator. So just be careful about that. One of them has to be negative. The interest rate, well, okay, we're going to assume it's still 4%. And then what they want us to find is n. Okay, so this is what we're going to find right here. Now we have to be a little careful when we find this because we're actually not going to be finding the number of years. We're going to be finding the number of quarters. So let's see. Let's just clear this off here. So 0, 4, okay, negative 5,000. That's still the same. Payment 0. And what is it? 56, 34, and 13 cents. And most of the time when you do this, you'll get a pretty standard answer. So if you get some jacked up answer, yeah, you might want to check your work. But all right, let's calculate this. So again, alpha, solve. Now, the answer here is 12. Okay, now, what a lot of kids might make a mistake here is they go, oh, okay, 12 years. Well, it's actually not 12 years because we were calculating in quarters, so it's 12 payments. Now, there's 4 per year, so if you do, obviously, 12 divided by 3, or excuse me, whoops, 12 divided by 4, that's going to be 3 years. So he's had the money in the bank for 3 years. Now, again, like if I had made a mistake there, if I had said 12 years, that makes absolutely no sense because we had up here, we had 7 years and it was only 6,600. This is less money. So you kind of have to, you know, just use your common sense here. Anyway, the finance app, if you get good at it, it's really, really good tool to use. And hopefully this helped you out. All right, take it easy. Okay, the last topic here is loan and savings tables. Now this one's going to be real quick. There's really not much to say about these. Normally the table will give you the amount per month per $1,000 or in this case Australian dollars or something like that. The key is to realize that this is a monthly calculation, not the full payment of the loan. So in this case, like look at this problem. It says the table below gives the monthly repayments for a loan of $1,000. Australian dollars, excuse me. The interest rates are 18 wow, that's a high interest rate. 18% per annum and 18.5 per annum, respectively. Okay, so based on the number of years of the loan, okay, so obviously, $1,000. If you pay it back over 5 years, your payment per month is going to be lower, but you're going to end up paying more money because you're going to pay more interest. Okay, obviously, it's going to be a higher payment here. Okay, so now notice that this is monthly payments per $1,000 or Australian dollars. Okay, so if it was $8,000 or $10,000 even, let's say $10,000, you would have to multiply each of these by 10 to get the monthly payment. Okay, so what I'm going to do here is I'm going to do a problem on this. It's real short. Okay, so part A says find the monthly payment on a loan of 1,000 Australian dollars at 18.5% over 1 year. Okay, well that just shows if you know how to read this or not. So 18.5% 1 year is going to be that. So it's going to be 95.07. Okay. Now, that's not difficult, but I don't know. Sometimes kids have trouble reading these. Okay, and then let's look at the last part here. Okay, it says calculate the total amount to be paid on a loan of 8,000 Australian dollars over 5 years if the interest rate is 18%. Okay, so this is good. Okay, so this is a typical problem. So monthly repayments are based on 1,000 AUD or AUD. Okay, so they say, let's see, 5 years. Okay, so we're going to use that one over 18%, right? 18%. Okay, so we're using this figure, but this is per 1,000, and they say the loan is 8,000. Okay, so how many thousands do we have? We have 8 of them, right? So we just do 2614 times 8. Okay, and I'm just going to do that on my calculator. 26.14 times 8 is $209.12. Okay, so that is your monthly payment. So that might be like a car payment or something like that. Okay, calculate the total amount to be repaid by the loan over 5 years. Okay, well this is per month. Okay, so how many months are in 5 years? Well, you just do 5 times 12, which is 60. So we're going to take 209.12 and we're just going to multiply it by 60, and we get $12,547.20. Okay, now just think about this. 18% is a really high interest rate. But think about how banks make money. Like look at what you borrowed. You borrowed 8,000 here, and then 5 years later you've paid back 12,000. So a question might say, well, how much total interest did you pay? We could do $12,547.20 minus the initial amount, which was $8,000, and you're going to get 27,454. So you paid over $4,500 in interest. That's absurd, for an $8,000 loan. So it's important, like as you get older and stuff, and you start to take out loans for cars and things like that, that you understand this. I just bought a car recently, and the interest rate, in the United Arab Emirates, the bank, the interest rate they put on the loan forms was not the real interest rate. They were calculating it with the simple interest rate as opposed to a compound interest rate, and I called the guy on it. It was pretty funny. It didn't really change my payments or anything, but he said I was the first one ever to do that. So, small victories in life, I guess. So anyway, folks, that ends up all these videos. If you've watched all these, I'm sorry you've had to listen to my voice for this long. But it's a long slug, but hopefully this stuff helps you out, okay? And going forward, I just have one last thing to say to you. All right, keep calm and rock that exam, okay? All right, if you have any questions, shoot me an email or make a comment, and I'll be happy to help you out. Good luck, everyone. Take care.